So aka A level chemistry year one or AS level chemistry, you could say. Um, Equations. So a lot of equations. So let's go through them. So we've got Na. Actually, let's start from here. So group two elements, we got M to M2 plus 2 minus, calcium to Ca2 plus 2 minus. Obviously, that's not the full equation. It's with water. But basically, when group 2 metals react with water, they oxidize from a 0 to a +2, therefore forming M2 plus ions, forming a metal hydroxide and a hydrogen. And water in this reaction between group 2 metals, water is the oxidizing agent. So you can see here, beryllium, it doesn't react with water. Magnesium reacts very slowly, calcium steadily, strontium fairly quickly, and barium rapidly. They react more readily down the group as the ionization energy decreases. Now we've got with more equations. So Ba2 plus aqueous plus SO4 2 minus aqueous to form BaSO4 solid. BaCl2 aqueous plus FeSO4 aqueous to form BaSO4 solid plus FeCl2 aqueous. The ionic equation for neutralization, H plus aqueous plus OH minus aqueous to form H2O liquid. And remember, you need to know the states, what states are in, because I think learning the states is also very hard as well. Then we've got TiCl4 gaseous state plus 2mg liquid to form Ti solid plus 2mg Cl2 liquid. TiCl4 gaseous plus 2mg liquid to form Ti solid plus 2mg Cl2 liquid. And in this reaction, magnesium is the reducing agent. Now I've got calcium oxide, CaO solid plus 2H2O liquid plus SO2 gaseous to form CaSO3 solid plus 2H2O liquid. Then CaCO3 solid plus 2H2O liquid plus SO2 gaseous to form CaSO3 solid plus 2H2O liquid plus CO2 gaseous. Then I've got displacement reactions, Cl2 aqueous plus 2Br minus aqueous to form 2Cl minus aqueous plus Br2 aqueous. Then I've got Cl2 aqueous plus 2I minus aqueous to form 2Cl minus aqueous plus I2 aqueous. Then I've got Br2 aqueous plus 2I minus aqueous to form 2Br minus aqueous plus I2 aqueous. And now I've got this reaction, the reaction of sodium hydroxide and chlorine. 2NaOH aqueous plus Cl2 gaseous to form NaCl aqueous plus NaClO aqueous plus H2O liquid. 2NaOH aqueous plus Cl2 gaseous to form NaClO aqueous plus NaCl aqueous plus H2O liquid. And you can see the oxidation state of chlorine. In this case, it's 0, obviously, it's element by itself. 0 to +1 in this case, and also -1 in this case. And this is an example of a disproportionation reaction, as chlorine is both oxidized and reduced. Oxidation state of chlorine goes up and down. Then I've got Cl2 gases plus H2O liquid, a reversible reaction to form Cl2 gases plus H2O liquid to form reversible reaction 2H plus aqueous plus Cl minus aqueous plus ClO minus aqueous. Then I've got, and again, this example of disproportionation reaction as chlorine oxidation state of 0 to -1 and +1. Chlorine is both oxidized and reduced, therefore disproportionation reaction. Then I've got 2Cl2 gaseous plus 2H2O liquid, reversible reaction to form 4H plus aqueous plus 4Cl minus aqueous plus O2 gaseous. Then I've got NaF solid plus H2SO4 liquid to form NaHSO4 solid plus HF gaseous. Then I've got NaCl solid plus H2SO4 liquid to form NaHSO4 solid plus HCl gaseous. Then I've got NaBr solid plus H2SO4 liquid to form NaHSO4 solid plus HBr gaseous. And now this reaction of sodium bromide with sulfuric acid is another part as well. Then I've also got 2HBr gaseous plus H2O liquid, 2HBr gaseous plus H2SO4 liquid to form Br2 gaseous plus SO2 gaseous plus 2H2O liquid. So I've got that and that. Then I've got the reactions of sodium iodide, NaI solid plus H2SO4 liquid, NaHSO4 solid plus HI gaseous. Then I've got 2HI gaseous plus H2SO4 liquid to form I2 solid plus SO2 gaseous plus 2H2O liquid. Then I've got 6HI gaseous plus SO2 gaseous to form H2S hydrogen sulfide gaseous plus 3I2 solid plus 2H2O liquid. and H2S is toxic and smells of bad eggs. The reason I said this is because in the exam it could say to you like, give the 3 equations of the reaction of sodium, of the reaction which produces hydrogen sulfide, and it is these 3 reactions. Then I've got Ag plus aqueous plus X minus aqueous to form AgX solid. Then I've got ammonium ions reacting with OH minus ions, NH4 plus aqueous plus OH minus aqueous to form NH3 gaseous plus H2O liquid. Then I've got Ba2 aqueous plus SO4 2 minus aqueous to form BaSO4 solid. Then I've got CO3 2 minus aqueous plus 2H plus aqueous to form CO2 gas plus H2O liquid. Then I've got decomposition of ozone equations: O2 UV light, oxygen free O free radical plus O free radical, then O2 plus O free radical to form O3, Cl dot plus O3 to form ClO dot plus O2, ClO dot plus O3 to form 2O2 plus Cl dot. And if you cancel them out, so chlorine free radical that leaves, that pairs them left hand side, right hand side, then you're left with 2O3 arrow to 3O2, and that is the overall equation for ozone. And Cl dot, the chlorine free radical, is a catalyst. So I've also got another one, CCl3F, you would UV light to form CCl2F radical plus Cl dot free radical. And I've got ethene plus sulfuric acid, so ethene H2C11CH2 plus H2SO4 to form CH3CH2OSO2OH. Then I've got, that's ethyl hydrogen sulfate and alkyl hydrogen sulfate. Then I've got ethyl hydrogen sulfate, CH3CH2OSO2OH plus H2O to form CH3CH2OH, ethanol plus H2SO4. And this is the overall equation: H2C 11CH2 plus H2O arrow H2SO4 to form C2H5OH. And then I've got alcohols. Alkenes can be dehydrated to form alkenes: CnH2n plus 1 OH to form CnH2n plus H2O, where CnH2n is alkenes. I've also got hydration of alkenes: CnH2n plus H2O, reversible reaction to H plus to form CnH2n plus 1 OH. Then I've got these 3 equations: C6H12, well, actually these 3, but first one, the fermentation of glucose, C6H12O6 aqueous, arrow, you can see the conditions, 30 to 40 degrees Celsius with the yeast, to form 2C2H5OH aqueous plus 2CO2 gaseous. I've got 6CO2 plus 6H2O to form C6H12O6 plus 6O2, C6H12O6, arrow 2C2H5OH, aqueous plus 2CO2 gaseous, so literally exactly that reaction. Then I've got 2C2H5OH plus 6O2 to form 4CO2 plus 6H2O. 2C2H5OH plus 6O2 to form 4CO2 plus 6H2O. Now these really aren't equations, I guess they are. RCH2OH plus oxidizing agent, primary alcohol plus oxidizing agent to form an aldehyde, RC11O and a H plus H2O. Then RC11OH aldehyde plus oxidizing agent, in this case reflux. Now with aldehyde to carboxylic acid, like primary alcohols to aldehyde, oxidizing primary alcohols to aldehyde, you don't need reflux. Oxidizing aldehydes to carboxylic acids, RC11OH plus oxidizing agent, you do need reflux to form RC11OH carboxylic acid. Secondary alcohols, R1 C or 2HOH plus your oxidizing agent. In this case, again, you need reflux to form R1 R2 C11O plus H2O, your ketone. Secondary alcohols can be oxidized to form ketones plus your water molecule. And this obviously isn't a reaction, an equation, but it's converted between units: meters cubed, dm cubed, centimeters cubed, meters cubed to dm cubed, you tan by 1000, dm cubed to centimeters cubed, tan by 1000. And this is what I would do in the exam. As soon as you open the paper, just draw these 3 out in order: meters cubed, dm cubed, centimeters cubed. Remember, to get from one to the other, you tan by 1000, and if you want to go the other way around, you just divide by 1000, because these 3 are extremely common units used in AQA level chemistry. Obviously there are a couple other ones, but these are extremely common, and if you are comfortable with them, you're going to get those extra marks.